Hello, welcome back. My apologies, the previous video was a bit too long, but unfortunately, I didn't want to start all over again the Newton's law of cooling for the second question where you became a detective. That's why it took a bit of time. Hope you enjoyed the question. Now, look, all of you have at some time or the other in your life, especially in a community, heard rumors. And it is worse in a school. Someone starts something and pop, 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 pop. People will have heard, I heard so and so saying that. Who? Oh, so and so saying that. Oh, no, yes, I heard so and so. So, in other words, very quickly, who told you? He. Who told you? She told me. She told me. So, it goes back. So, rumor spreads fast, right? But not always. It depends on the kind of rumor. If it's something personal, people will do hear if an incident happened, but it will take longer because people are discreet. But if it's a general rumor like, A-level exams are cancelled for the year, oh my God, you will hear it within 2 minutes, million people will have heard. So this question is based on something similar. The rate at which a rumor spreads in a school is proportional to the product of the proportion of the pupils that have heard the rumor. We don't know the number, a proportion, like you see, if 20 out of 2000 students have heard, the proportion will be 20 out of 2000. Or it is a fraction, maximum the whole school is considered as 1. And the proportion that have not heard. Rumors are blah blah blah, I'll come to that. If X is the proportion of pupils who have heard the rumor at T hours. So in other words, they have identified the variables for you. X is one variable and X is increasing. So dx by dt is proportional to the proportion of pupils that have heard the rumor. X is a proportion and 1 minus X haven't heard the rumor. So dx by dt is proportional to X times 1 minus X, or dx by dt equals kx times 1 minus X. Positive K because X is increasing. The proportion of people who have heard the rumor increases because, okay, now in a school dance, something happened. And initially, maybe 1 out of 49, maybe there are about 10 students saw what happened. There are about 490 people in the gathering. Yeah? So, 1 out of 49 of the students have heard it. So, let's first solve this equation. 1 over x times 1 minus x dx equals k dt. Let's look at the left hand side. I can't integrate directly. I can't use substitution, but it's an algebraic fraction. Numerator is less than denominator. The derivative of numerator is not, the derivative of denominator is not in the numerator. So and I can factorize the denominator. So partial fractions. So 1 over x times 1 minus x equals a over x plus b over 1 minus x gives you 1 is equal to a times 1 minus x plus b. X, put x equal to 0, a equal to 1, put x equal to 1, b equal to 1. So this becomes integral 1 over x minus plus 1 over 1 minus x dx is integral k dt. Understood so far? So anytime you frame the differential equation, get rid of the proportionality to bring a constant of proportionality, then separate the variables. When you want to integrate, use the rules of integration. Not everything is as straightforward as you think. Okay? I need to show this, so what I'll do is I will rub this off because I have Now let's look at this. A rumor starts in a school dance and initially 149. So t equal to 0, x equal to 1 over 49. After 2 hours, t equal to 2, 1 over 13. You're given two sets of conditions because when I integrate this, I'm going to get two unknowns. Let's integrate this. I had integral 1 over x plus 1 over 1 minus x dx equals integral k dt. So ln x minus ln 1 minus x. Why is it minus? Because when I differentiate 1 minus x, I get a minus 1. So I should have written a minus of minus 1. So let me do that. I'll write this as minus and a minus 1. The numerator is exact derivative of denominator. Is equal to kt plus ln a. So ln x minus ln 1 minus x minus ln a equals kt. Put them, so ln x over a times 1 minus x equals kt. So x over 1 minus x is a e power kt. So that's my solution. X over 1 minus x equals a e power kt. So I have used that information. Very good. Now I need to find a, I need to find k. T equal to 0, x equals 1 over 49. So 1 over 49 divided by 1 minus 1 over 49 equals a e power 0, giving you a equal to 1 over 49 divided by 48 over 49, which is 1 over 48. So I can say x over 1 minus x is 1 over 48 e power kt. After 2 hours, 1/13th have heard, because as obviously the rumor started, hey, yes, that happened. She tells him, he tells her, she tells her, she tells him, he tells him, he tells him, somebody rings the other person who is dancing at the other end. So slowly, remember, 1 over 49 is smaller than 1 over 13. So more proportion have heard, more people have heard the rumor. So now, I'm putting t equal to 2, x equals 1 over 13. So 1 over 13 over 1 minus 1 over 13 is 1 over 48 e power 2k. What does it give you? 1 over 13 divided by 12 over 13 is 1 over 48 e power 2k. So 1 over 12 is 1 over 48 e power 2k. So therefore e power 2k is 4. So 2k is ln 4, k is ln 2. You understand that? But there is an easier way instead of, and then therefore you can say e power ln 2t. But there is an easier way of looking at it. This, can I say, e power k whole squared is 4. When you take square root, I get plus and minus 2. But e power cannot be negative. So therefore, e power k equals 2. To me, that's easier than that. Why? We will see when we substitute. So I have this equation. X over 1 minus x is 1 over 48 e power kt. Let me write that equation. So x over 1 minus x is 1 over 48 e power kt. Now remember, x power m whole power n is x power mn. So can I write this as 1 over 48 e power k whole power t? Why? I don't have any here. That's why. But e power k is 2. So therefore, x over 1 minus x is 2 power t over 48. Well, sir, but I couldn't think of it. You are clever. I only know how to find KSLN2. Nothing wrong. Or x over 1 minus x equal to 1 over 48 e power ln2 t, which you write as 1 over 48 e power ln2 whole power t, which is 1 over 48 2 power t, because e power ln x is x. Either way, I get the same answer. Clever, isn't it? Right. I just made up this question. I was thinking what would be, these are standard questions. Okay. So, x over 1 minus x equal to 2 power t over 48. Cross multiply. 48x equals 2 power t minus x times 2 power t. So, 48x plus x times 2 power t equals 2 power t. So, x times 48 plus 2 power t equals 2 power t. So, x equal to 2 power t over 48 plus 2 power t. Pretty interesting question, isn't it? So lovely. And this is a common day, this is a common occurrence. Rumors go on every now and then on the football field, in the classroom, in the community, in birthday parties. When there's a group of people, oh my God, rumors abound, especially in the exam. I will talk to you about a very interesting rumor which almost cost me dearly. Just out of interest, of course. So let's first finish this. Show further that after 5 hours, so t equal to 5, what is x equal to? 2 power 5 over 48 plus 2 power 5. That is 32 over 48 plus 32. 32 over 80, which is 2 over 5 times 100 is 40%. So you have shown that after 5 hours, 40% of the students have heard the rumor. Well, yeah, the story was when I was doing my A-level, the day before the physics, of course, I was quite good at physics, chemistry, maths. I was not outstanding, but I was quite good. And one of my friend's brothers came and said, hey, you guys, me and my friends were revising. You know what? Yesterday, first day we had the exam. In those days we had to do English, a local language, then physics, chemistry and math. 5 exams. So I said, yesterday's English paper, I know somebody in that college, he had got a leak. And whatever questions that he got as a leak came in the paper. Now today he has given me, these questions are sure to come in the physics exam. You guys, come on, use it. Which was stupid. Now I know that was wrong. But those days I was 15, you would do it. It's unfair. And I learned the hard way. So we decided, okay, we will go through all those questions. We spent about 3-4 hours going through every one of those questions and remembering them well. Next day I go to the exam. I open the paper. Not one question from what he had said. I was devastated. I was a good student. I should have easily, if I had not bothered going over those things, I would have done better. But stupid that I am, I believed the rumor and I ended up in a soup. But fortunately, whatever revision, it took me about 10-15 minutes to gain my composure. It was a 2.5-hour exam. Then I started attempting the questions. So question 1 came through, question 2 came through, question 3 came through, and I built my confidence. I ended up getting about 63%, I think, whereas normally I would have got about 75, 80%. Well, that cost me. But in a way, it didn't, because my maths was always good. I ended up doing my master's in maths and then ended up being a teacher, as a result of which I traveled all over the world. So, but my advice is please don't believe in these rumors. Every year you come across these are the probable questions. Probable questions and rumor are two different things. Probable question means maybe your teachers have seen, look, for the past 3 years, you haven't got questions on integration by parts, reduction formula. So this might come this year. That's a probability. That means you study everything and you give a bit more importance to that. Go over that. These are the topics you better revise. They might turn up. That is teacher's experience talking. But your friend comes and says, look, my neighbor works with Edexcel. He told me these questions are coming. That's rubbish. Do not believe in rumors, number one. And be honest, believe in yourself. You don't need those things. You can do and get great marks just by revising and working hard instead of these shortcuts. Do not do it, please. I learned the hard way. Of course, that was nearly 60 years ago, 1963, 2023 almost. So it's almost 60 years ago. But that doesn't matter. I paid the price. I should have got 75, 80%. I got 63%. But not all of us are so lucky, because in a panic, we might forget everything. So please, especially when people come and say, I've got a leak, I know this is going to come, so and so told me, don't believe those rumors. Believe in yourself, do your best, attempt honestly. Okay? Well, that concludes the whole of A-level course. Of course, there are a number of beautiful questions which are very interesting. If I'm doing it in a classroom, I spend time trying to talk about how the snowball develops, how chemical reactions are used. But unfortunately, the questions like that rarely come in the exam. It's more to see the application of differential equations than with exam type of questions. So I don't want to confuse you with that, but if you're interested, you can go back to some old past papers or old A-level textbooks, say in the 80s and 90s, on differential equation. You will see some beautiful questions. Very challenging, very interesting question. I used to do them in the classroom before, but slowly and steadily things have changed. The approach has changed. So what I have done is basically gone over the various topics of A-level math and pure maths in brief, to give you, to go over what you have already learned in school, to reinforce the concepts and look at some examples. This, whatever I have done, is in no way complete in itself, no way exhaustive. It is just giving you a prod to go and improve your grades. I hope you are able to do it, and I hope you are benefiting, or you have benefited by all these videos. I do not know, this is now March. I wanted to finish before the April break so that people who are sitting A-level exams in June 2022 are able to use my videos along with their classwork and what their teachers have taught as revision. See, my idea is this. I want to leave it out in the open there. It's like, there is a path leading to A-level pure maths. I've just planted a tree with a shade. So as you're walking along over the 2-year period, I mean, figuratively speaking, metaphorically speaking, you come under this tree. If you wish to, if you're good, you're not tired, you keep walking. But if you're tired, you can rest. All the lessons I've done are the shade. The shade helps you. You sit and think what you learned. So all my videos will help you go over what you learned on your way to A level and university mathematics. Thank you very much for those who have watched these videos and have benefited by it. Please pass this information to your juniors who are in year 11, year 12, so that they also can benefit. It's out in the open. I'm not interested in comments. I'm not interested in suggestions. I have done what I feel I should share with you. If you like it, good. If you don't like it, no harm done. You don't have to watch it. Okay? All the best. God bless you. Get on with your life. And I wish you everything the best in your lives. Bye bye. Goodbye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.